Hi, so it's been a while, but today I'm going to show you how to write code to detect your April tags and decode them using easy OpenCV. So if you have a camera and you just want to learn how to decode the April tags for this year's challenge, then you can use easy OpenCV to do so. So for this, I'm going to be using easy OpenCV simulator, which basically lets you test your pipelines without having the physical camera with you. So before I dive into it, let me show you what my code actually does. So here, as you can see, I have AprilTag 1, which successfully detects, as well as AprilTag 22 and 23. And it mentions the different motifs at the top as well. And with this, you would be able to write conditionals to control robot actions. So firstly, under the processor package in team code, I created a Java class named my AprilTag pipeline. So let's get started with the code. I have firstly my package and followed by imports, which you can add as you write your code. My class declaration, extending the OpenCV pipeline, which lets our code receive camera frames and process them in real time. This line, private array list, AprilTag detections, latest detections, a new array list, stores all the tags detected in the current camera frame, and every time we update it with like the latest tags. Every time we detect, we update it with like the latest tags. Then we have camera like attributes, and this is based off of your physical camera. So we have camera intrinsic, whatever. So this comes from your physical camera's calibration. So fx and fy are the focal lengths of the camera in pixels, and they affect how the image is projected into 3D space. While cx and cy are the optical centers of your physical camera, and this is basically the center of like the camera lens of which your like camera points out of. Together, these numbers lets us calculate the real world position and orientation of each AprilTag. Then we have the tag size in meters, which is around 16.6 centimeters. And this lets us figure out how far the tag is from the camera. So if this like number is wrong, then the robot's distance calculations will be off. But we're not doing that in here. We're just decoding the AprilTags numbers, but that's the tag size. Then we have a private long native detector PTR, which basically means that it's like a pointer for the like actual detector in memory. So this is like for C++, but since Java can't directly access the C++ object, so it stores it as like an address in the memory as a long, and then we pass this pointer back to the native library to detect the tags. Then we have private match or private matrix gray, which equals new matrix. So we basically create a grayscale for the image, and this is good because AprilTags can be better detected and seen on a grayscale because color isn't needed. As you know, AprilTags are like black and white, so it's faster to process. Then we have inside our init method, we firstly have native detector PTR. So the tag ID here, tag underscore 36H11, is the type, it's like the family of tags we want. So like tag 20, 21, this is stored in this tag family. So that's group of numbers is stored in like this tag group. There are 3 threads, which lets us run processing time faster, and 3 quad decimation reduces image resolution internally for faster detection. And then this is this detector is stored in native detector PTR, so we can use it in every frame. Then we have our public matrix processor frame. So the process frame is called for every camera frame. We convert the image to grayscale here also because AprilTag detection doesn't need color, as said before. It works faster without color. Then we have latest detections, AprilTags, GNI, and their parameters. And we run the detector on the grayscale image, and it returns a list of like the detected tags with their IDs, coordinate positions, and 3D pose. And we save that in a list called latest detections. And this is basically what it's doing. It's storing all of our detections in a list, and it's like giving whichever one we return. So over here, for every tag detected, this is just custom code to draw a green box around the April tag. And this is just to help, or like for visually for us humans. You don't really need to do this if you don't want to. Then I'm just like positioning text by like each tag, and I'm just putting the ID plus the detected ID number. And then afterwards, you can use this ID detected to create conditionals. So like I've done here, if detection.id equals 21, you can do this to like perform motor actions, autonomous routines, paths, whatever. But right now, I'm just putting in text, which basically says the motif and then the order of the colors, such as green, purple, purple. And I'm just putting fonts and all and positioning this properly. And then I've done that for each ID with their distinct color pattern. And if none is detected, then it prints out no tag detected. And if it is detected, then it prints out the detected tag ID plus detection at ID. And now we can see this run. Alright, so just running the simulator, and it will take a minute to start. Alright, so as you can see, the simulator started loading, and after a minute or two, it will turn on. So in here, you first have your pipelines, which you have created. It comes with default pipelines, I believe. I'm not exactly sure about the other ones because I haven't really tested with them. But here's the pipeline I created, my AprilTag pipeline. And as you can see, there's no AprilTag right now, so nothing happens. But here in sources, you can upload the images of the AprilTag, so you can upload the AprilTags. I have done so for AprilTag 23. So if I go to default pipeline, whichever one that is, and if I go to AprilTag 23, so I'm at AprilTag 23 on default pipeline. As you can see, there is nothing, no output is being shown or anything. However, if I go to my AprilTag pipeline, then you can see that it detects the tag ID as 23. It's drawing the green box around it, as well as presenting the motif to be purple, purple, green. So that's it for today, and I hope you liked this video and it would help you somehow this season. And please help me on this journey by subscribing and liking. Thank you. Help me on this journey by subscribing and liking. Thank you.